My name's Simon Cook. I'm a cloud architect working for Salesforce in the UK. So my watch is just reminding me that it's 1 o'clock in the morning, my time. So if I nod off halfway through, just shout at me and prod me and I'll wake up. I've been with Salesforce about 2 years. I work in our pre-sales team for the platform. So I help customers build custom applications based on our platform. And what I'm going to present today is not a product, but a demo that we built for a customer. And it's a demo that used a combination of Service Cloud platform and augmented reality for an advanced field service use case. So your favorite slide of the day. Hopefully, this will be the most boring slide of the deck. But I do have to remind you that we're a publicly traded company, so I'm not talking about futures today because of the nature of my presentation, but just bear that in mind. So what we're going to go through today is a quick introduction to who I am and my colleague who helped me build this demo and why we did it. Then we're going to talk about what augmented reality is and what it means to applications moving forwards. Then I'm going to talk about what does Salesforce have to do with augmented reality, because that's probably a question you're asking yourselves. I'm actually going to do 3 or 4 demos today, depending on how much time we get and whether the demo gods are with us or not. And then I'm going to go through in a bit of detail about how we built the app. And then I'll try to leave some time at the end for questions. And if you have any questions at the end, if you could just use the microphones, because we're recording the session today, so we can pick up the questions as you ask them. So this was actually built, this demo was built, because the chap on the right-hand side of the slide, a guy called Joel, wanted to show his customer something different, something innovative around field service. And the customer makes big projectors, big cinema-style projectors, and they're sending field engineers out all the time to go and fix these projectors. And as you can imagine, with something as complicated as a cinema projector, it's got lots of moving parts. It's got lots of parts that have different lifespans. It's got lots of parts that need changing and upgrading and generally needs to be looked after. So Joel sort of put out this request for anyone that knew anything about augmented reality so we could build an AR demo with service in mind. So I had just finished doing a course on augmented reality, so I just wanted to build something cool, if I'm honest. That was my reason for doing it. So I replied to Joel and said, yeah, I'm sure we could put something together. And the demo we put together was built in about 3 days. So it gives you an idea of how agile and quickly we can build things on the Salesforce platform as well. When I think about innovation, and I'm sure you've been to many sessions today where we've talked about all the digital touch points, you know, the sort of next generation of applications that we're building, everything around intelligence and Einstein, this idea of the fourth industrial revolution. When I talk to customers in the UK, we talk a lot about these technologies that I show on this slide. And although Salesforce don't directly make or build these technologies, what we can do is we can interact very closely with them. And if any of you have been to any IoT sessions today or heard anything about IoT today, we talk a lot about context. So we talk about behind every device there is a customer. And behind every customer there's going to be a level of service. And you can either delight your customers by providing them with excellent service, or you can annoy your customers with providing them not such good service. So what we're able to do with our Salesforce clouds is provide the context that sits behind all of these. Now if you look at things like vision prediction, object detection, machine learning, IoT, they're very close to what we do at Salesforce. We have an IoT cloud. We have our Einstein products that allow us to do things like vision detection, and you'll see as part of the demo we use Einstein to do the vision detection. Difference between object detection and vision detection is that Einstein can not only tell you classify what is in a picture, but with object detection we can count the number of objects that are in a picture. We can tell you the percentages. Ideal for something like a CPG use case where you want to count the number of items on a shelf. You can just take a picture of that shelf and the AI will tell you how many objects you've got on those shelves and what percentage of those shelves are taken up by those particular objects. Obviously, blockchain has been in the news a lot this year, mainly because of the cryptocurrencies built on top of it. But actually, when you look at blockchain and some of the other uses for blockchain outside of currency, it can become really interesting. This concept of creating a trail of information about a product, about an item, about something that cannot be changed. It's an online distributed journal that represents the life cycle of an object. So in today's world, where retail companies are looking to source ethical products, being able to go back to the root of a product and see who picked it, when it was picked, how it was picked, is really key. And we can save all that information in something like blockchain that we can share it with everyone. And machine learning, obviously no Salesforce presentation is complete without the words AI and machine learning in them, but we are obviously building all of that technology into our platform. And today I'll show you some ways in which we use machine learning outside of the core platform. The other bits that we're not really going to go into too much detail today are things like voice user interfaces and wearables, so smartwatches. And does everyone have an Alexa or Google Home or a HomePod at home? If I have to listen to Happy once more time, because it's the only song my children can ask for, so we listen to Happy on a daily basis. But today, the demo I'm going to show you makes use of various components on this slide. So we're going to use an augmented reality app running on an iPad. We're going to use IoT to actually tell us what device is broken. So the IoT piece tells the field service engineer where they should be going. We're going to use sort of a voice user interface. I'm going to use the dictation technology built into iOS. And we're going to see some machine learning in the form of visual prediction as part of the demo. So what is augmented reality? This is the definition from Apple's website. The reason I chose to use their definition rather than anyone else's is because these demos are built using Apple's AR kit. So I'm using a beta version of iOS and using AR Kit 1.5 for these demos. But just take a second to read through that slide. Basically, what it's saying is that AR Kit will give you a view of the real world in which you can superimpose virtual objects. And those virtual objects can make up a virtual scene. Did everyone see the keynote this morning? At the end of the keynote, they had that virtual scene with all the chairs and the tables. Right, that's an example of something that you can do using augmented reality technologies. Now, AR Kit's really clever because it can do things like sense the amount of light that's entering the camera, so it will light your virtual objects accordingly. So if you dim the lights in the room, your virtual scene will dim as well. And that provides a level of continuity between the virtual objects and what's happening in the real world. So as well as being able to just render objects in the virtual world, we're able to make use of the real world information that we get through the camera, through the iPad's various sensors, and make that really realistic in terms of what you can do with those scenes. And it sort of changes the way you start to look at user interfaces. Because rather than your UI being restricted to the size of your screen, your UI is restricted to the size of the environment that you're in. So a quick demo to show that. And this is actually using a piece of code from Apple's developer kit. It's a very simple demo, very similar to what you would have seen this morning. So we have a view of the real world. Here you all are. And you'll see that my cursor on the screen changes when it picks up a flat plane. So it's doing something called plane detection here. So it's working out where the floor is, and it can also work out where the walls are. And then what I can do is I can add my virtual fridge into the scene. For some reason, it's a tiny fridge. So let's just try that again. Let's just try picking up the floor again. That's a bit better. That looks better. So now I can add my fridge into the scene here. And you can see I've got the little plastic fridge here that this is a virtual representation of. So I can now start moving that around the scene and see where would it. I mean, that's a bit of a hazard on the end of the stage there, but you get the idea. I can start having an idea of what that would look like if I placed it in a scene. And you could then start placing other virtual objects in this scene as well, such as chairs and lamps and other, as you saw earlier. And then we can start sort of manipulating the scene and moving these objects about, seeing what our scene would look like if it had these objects in there. So this, again, quite a powerful. You see how well lit the chair is? Because the lights from the ceiling are directly down onto that model. And you can see the top of the fridge is well lit. And that's AR Kit modeling lighting from the real world with the virtual objects that we put in that view. Another one I quite like, and this is just to prove to my wife that I'm not actually here on a jolly and I am doing some work, is this snapshot view as well. So I can take a picture. I can take a picture of the audience. I can push. There you go. I can push the button, and there you can see I've now placed a virtual picture of the audience in the view, and I can take as many of these as I want. And then when I've taken them, they stay in the scene where I took them. So you get sort of like a living copy of anything. I can take a picture there of the engineers over there, and maybe we can get wave this time. There you go. And then we can see that's what they look like waving, and that's what they look like when they're not ready for their picture to be taken. So you can start to see how really simply you can build some quite compelling applications using AR technology. And to give you an idea, that the source code for that picture demo is about 20 lines of code using AR kit. It's really simple. So that sort of thing is really simple to do. And actually, and the one with the chair is pretty simple stuff as well. So moving on. What's that got to do with Salesforce? I know you're still asking yourself that question. We will get to that. But what we set out to achieve was to build something different and something cool that was relevant to our customers. Because any IT company could stand up on stage and show you those 2 AR demos that I've just shown you, especially Apple, because most of it's their code, but don't tell them that. And then we thought, well, what about tying one of our clouds into that UI? And the idea that Joel had was Service Cloud. Because when you think about when you send a service engineer on site, and they may be seeing a device for the first time ever, wouldn't it be great if we could use Einstein image recognition to tell us what that device was? Wouldn't it be great if we could talk to Service Cloud and get all the knowledge articles related to that device to the field service engineer in real time? And then wouldn't it be great if we could do a virtual SOS call back to base with a field service agent and then log a case? So that's pretty much the demo that we built using the AR technology. And really what we want to do with the AR technology is, you'll see in the image here that I'm rendering these virtual panels on either side of the device, and we're pulling information back from the Salesforce org about what that product is, what its operational temperatures should be, what its operational temperatures currently are. We use IoT to get all the information about the fridge in real time. And then we present graphs on the right-hand side panel showing what the temperature should be and what the temperature is. And then we use sort of Einstein prediction to predict the lifetime of that device based on its current temperature and its current usage and how old it is. And this all begins with an event from a fridge. Has anyone seen any IoT events today, or aware of, anyone done any IoT work with our IoT platform? Excellent, cool. So we use, there's a brilliant trailhead on IoT. And if anyone has any interest in IoT or devices at all, it's really worth doing. And it's if you just do a search for electric imp, I know it sounds odd, and IoT on Trailhead, you'll find this, basically the Trailhead that we use to do all of the IoT part of the demo. And it goes end to end on using this electric imp device that has a built-in temperature sensor and a light sensor, how you can program that device to send you temperature readings, and then how you can use IoT Cloud to work out whether those readings are outside of operational norms. And if they are, you can raise a support case within Salesforce. So this is the fundamental building block of our demo. This is how we know that we need to send a field service engineer in the first place. So what we do is we take our fridge, this little fridge here, which actually does plug into the laptop and does cool a can of Coke if you need it to, or a can of beer, depending what time of day it is. And then we can put the electric imp inside the fridge, and as it heats up, we can switch it to cooling mode or heating mode, and as it heats up, we can send an event into Salesforce, we can log a case, we can work out which customer owns that fridge, what support contract they have with us, and whether we need to send them a field service engineer. And we can do this in a proactive way. Before the customer even knows there's a problem, we can have a field service engineer on the way with the right parts and with this application to help fix the fridge that they have. And the way this works is that the fridge sends us a whole bunch of events. And in fact, we don't care about all those events in Salesforce. Although that doesn't sound very nice. We only care about the important events. So we care about an event that's going to make our customer either very happy or very unhappy. If an event is just saying the fridge is fine, we don't need to know that, because we don't need to contact our customer at that point. But as soon as the fridge tells us there's something wrong, and there's something consistently wrong with this device, then that's the point we want to get engaged. And you can see here what I'm trying to show here is the fridge is sending us lots of events. Every 5 seconds, it sends us temperature readings. And they might be okay, they might be warm, they might be hot readings. Then the electric imp platform runs some server-side code that works out whether it's an event that Salesforce is going to be interested in. So if it's an overheating event, it will then forward that event to IoT Cloud. IoT Cloud picks up that event and then runs some rules in an orchestration engine to determine what action to take. In this case, it raises a case which alerts a field service engineer. And again, all of that is done based on the Trailhead for Electric Imp. So the knowledge demo. So this is the app that we built for the field service use case. You can't see it, but here it is. So if I just fire this up. So you'll see in the top left-hand corner, it's telling me that the scene is ready. This means that ARKit has picked up the scene. And the first thing ARKit does is it tries to map the real-world scene to the virtual scene. And it does that by picking up feature points. So if you point ARKit at a white wall, it won't work, because it's got no concept of tracking against a perfectly white object. It knows how you're moving the iPad, but it actually uses a combination of the sensors in the iPad and the visual scene to determine how you're moving and where it should render objects. So the first thing I'll do here is I'll point it at my fridge, and when I push this button, if we've got Wi-Fi, what happens now is we're now going to connect to Salesforce, and as we connect to Salesforce, we're sending a copy of this picture. We're using Einstein Vision to work out what the picture is, and then we're bringing information back from the Salesforce org to render it in these virtual displays. And just to show you, I've got my little desktop robot here as well. My daughter very kindly bought me for Christmas. And then we can also look at this, and you see it's determined that that's a robot, and it's determined that this one over here is a fridge. So that's showing you that the Einstein Vision is working. And then lastly, I can point at my iPhone over here. I might be pushing my luck a bit on this one, but we'll see if it picks up there you go, it's picked up the fact that that's an iPhone 8 Plus. And it's rendering information about these various devices. And you'll see over here when I look back at my fridge that I can interact with these objects. So if I stand over here, I can't see the fridge. But if I click on that, it makes it transparent, so I can see what's sitting behind the scene. And you'll see that while I'm doing this, all of these other things stay in place as well. So this is the concept that my user interface is no longer limited to my display. It's limited to the environment that I'm in. So I can open as many of these panels as I want in this room, and then I can walk around the room and view the various panels. Now, if you think that some of that text is a little bit small, I can pinch, and I can zoom out on that panel as well. So I can interact with this in sort of many ways. So what I'm going to do here is, I know that this fridge is overheating. I can see by looking at my graph here that its current temperature is higher than its high operational temperature. So what I can do is bring up my knowledge articles. So now what I'm doing is going to Salesforce. I'm using Salesforce Community, which is serving knowledge articles up from Service Cloud. So these are all live service articles that are sitting within my org. And I can click on fridges, and I can click on my particular fridge here, and I can get some information up about my fridge. I can even minimize that view and park it within the AR view and carry on working. And if at any time I need to go back to my knowledge, I can just simply click on that, and it will bring my knowledge back into view. So it's a really nice way of bringing the virtual world and all the information that we have in the Salesforce clouds to a single device that the engineer can use. So I'm still having problems fixing my fridge, so I need to phone a friend to get some help. And this is where things might get a bit tricky, because now I'm playing two roles. I'm the field service engineer when I'm stood over here, but I'm the service agent when I'm over here. And what I'm going to try and do here, we've got SOS enabled, so I can click the SOS button here. This really could go horribly wrong. And I can click OK. And now what will happen is the app will now dial back into Service Cloud. And if I've got a network at both ends, which I should have, you can see here that I've now got a call coming into Service Cloud. And then what will happen is Service Cloud will render the AR view in Service Console. So the service agent will now be able to see exactly what the end user can see. So now I can start getting advice from people within the service center about how to fix this particular device. And they can even, let me just remove those panels, and they can even start, and this is where it gets really tricky. This is like trying to tap your head and rub your stomach. I can start drawing on this view here, and then that drawing will start appearing on my iPad as well. So I can annotate the view remotely and have it displayed on the iPad. So that the engineers can start giving me information about what I should be doing, like don't unplug this or you're going to electrocute yourself, or unplug that first or you're going to electrocute yourself. So you can see how it creates a really compelling, sort of very interactive experience. So we're done. My field service engineers really helped me out, so I can just hang up on the service console. And then it can even record that session. So if I click yes now, it will create a case, it will record that session, and it will save it as part of that case for that customer. So going back to the app, so that's great. I fixed the fridge. It's all working again. But now I've run out of parts, and I need to restock my van because I've run out of compressors for the fridge. So what I can do now is actually log a service case from here as well. So I can go into here, and I can log a service case. I can put my email address in, order replacement parts, restock van for fridge compressors. That could have been worse. And then when I hit send, that will now create a service case within Salesforce for that service engineer to get parts restocked in their van. So that's the demo that we built for the customer. Now let's have a look about how we actually built that. So what we did is we took the IoT use case at the bottom, assuming that we have a case that needs a field service engineer to be sent out. And then what happens is you have this journey where from the device, we note that the fridge is overheated. We send an event into IoT Cloud, actually into Electric Imp. Electric Imp then forwards the events that we care about into the IoT platform. We execute our rules on the end of our IoT platform, and then we look up the customer, their asset, their product, and their service contract, and then we send all that information back to the device. In terms of the engineer's journey, we now know who our customer is. We know now that they have a Premier Proactive Support contract with us, so we're going to send them a field service engineer. If they don't, we call them up and ask them if they would like a proactive field service account. And then the engineer turns up on site, he scans the object, and at this point, what I do is I cut out that object from the middle of the scene, and I send that into Einstein Vision. And I say to Einstein Vision, can you classify this object? And it will come back and say it's a fridge or an iPhone or desktop robot. And then I merge that data with the contact, the account, the service contract, and the asset, and then I send that information back to the device, and that's what gets rendered on those side panels. Does that all make sense? So, and the rough order in which you build that. So the first thing we did is we went to Trailhead, we did the Electric Int Trailhead, we had our IoT. We then actually used standard objects in Salesforce. So I just used the standard account, contact, asset, product, and service contract objects that are built into the platform. I added a couple of fields for temperature, so temperature for the asset and temperature for the product. That was all I did. I think it took a couple of minutes. And then I created what's called an image classifier with an Einstein Vision, but more on that in a second. And then I created a REST endpoint, so a bit of Apex code that would take a request from the iOS device, and then it would send that information to Einstein, get a result back, do some SOQL. So I did some SOQL against the objects within Salesforce, and then I merged all that data together and sent that back to the iOS device. And then we just had to enable, add some knowledge articles to Service Cloud, enable what are called Service Cloud snap-ins. Anyone heard of Service Cloud snap-ins before? Right. So the SOS call, the logging of a case, and the viewing of the knowledge articles are handled by a Salesforce SDK. It's about 4 lines of code for each one. Even the SOS bit, it's only about 4 lines of code. I've got a slide later with the code on to show you how that works. But snap-ins are fantastic. They add a massive amount of value to these mobile applications. And then used Xcode to develop the app. And the nice thing about developing with Salesforce nowadays is you can use the tools of choice. So you can use tools that make you the most productive. Whereas before, we would give you any developer tool you wanted as long as it was console, right, in Salesforce. Whereas now I actually use a combination of IntelliJ and something called Illuminated Cloud 2 to do my Apex and my triggers and everything that I need to do in the org. And Salesforce DX to run all my tests. I actually used a beta version of Xcode, 9.3 and iOS 11.3, and the reason being it has the very latest version of ARKit in, and there was a couple of technologies that I wanted that were in the latest ARKit, but it will work on any iOS device running 11. If you have anything that's an iPhone 6S or better, you can run AR applications using Apple's AR kit. And the latest 2017 iPad or iPad Pros all run AR kit as well. They're just standard iPads, there's nothing special about them. And then I use a combination of some other tools. I use I use a product called Pour, which is very much like, if any of you have ever used Postman for doing REST and SOAP requests. Pour is like a Mac OS version of Postman that's very Mac OS-ified, so it's pretty and looks like a Mac application. It's very good, actually. I like it a lot. Photoshop for doing all of creating all of the images and icons and bits and pieces that I need to use. I use a product called Unity for actually something that I didn't show you today, but the other thing we enabled was for the ability for a service agent to see a 3D model of the fridge or the device within Service Cloud, and they could rotate it and move it about, zoom in and zoom out. So they would have, really sort of merging the lines between reality. So a Service Cloud agent could view that, and I use something called Unity in their WebGL 3D engine to allow me to have, I built a Lightning component for Service Cloud Lightning, and I built a Visual Force component for Classic, so we can embed those items directly into the org. An application called Blender for doing all the 3D asset creation. And then anyone in the audience ever used Automata or Automator, however you want to pronounce it? If you own a Mac and you've never seen this, you must use this. It's built into Mac OS, and it enables you to automate anything that you do on Mac OS. It's amazing. So when you program Einstein Vision, you take a lot of photos of something, and you put it in a directory, and you create a zip file, and you upload it, and you then say to Einstein, this is a robot, or this is a fridge, or this is a whatever. And if you need to rename and resize all those images, it can take a long time, whereas Automated just does it, right? You just point it at a directory, you say, take all these images, resize them, rename them, make them sequential, and then zip them. And it does it at a click of a button. It's really, really powerful stuff. Anyway, and then if anyone saw the IoT session earlier, this is the electric imp console. On the right-hand side, the top right is the code that's running in the electric imp device. So this is the code that runs in the device that takes our temperature measurements, forms a little packet, and then sends them to the server side. On the top left-hand side is the server-side code that takes the packet from the device and then forwards it into IoT Cloud. And again, if you do the trailhead, all of this will make perfect sense. In the panel in the bottom are the events that we're being sent. So you're seeing the raw event data as they're being sent to us. Then what happens is in IoT Cloud, we have a state machine. And our state machine allows us to define what state our device is in. Normal, high temperature, high humidity, or the door's been left open. We don't send out a field service engineer in there if the door's been left open. But it's good to know. Because if the door's open and it's overheating, there's a clue. You can phone the customer up at that point, just ask them to close the door. Then you have a set of rules that execute against those states. And the reason states are so good and state machines are great for IoT is because they scale brilliantly. Rather than doing lots of if-then statements, you can just write a state machine, write your rules within a certain state, then you define how you transition from one state to the other, and it will scale for millions of devices. And then we have Traffic Inspector. So we can then view our traffic in near real time. So as events are coming in and our fridges are overheating, we can actually see that happening real time. Not so interesting when you've only got one device, because only one balloon will ever be blown up, and it'll only ever be 100%. But if you've got hundreds of thousands of devices on the end of this, and it's a good idea to see at any given time how many devices are in a certain state, then this is really useful. Next, as I said earlier, I use standard objects within Salesforce. So this is just a view of Schema Builder, assets and cases and contacts and contracts with some extra fields on them. And then I used Einstein Vision to classify the images. Has anyone ever used Einstein Vision here? Okay, cool. So the latest APIs are great because you can use zip files now, and it makes everything a lot easier than it used to be. But basically what you do is you define your label. So I said, what items do I want Einstein to understand? And I put about 7 or 8 in, iPads and iPhones and fridges and desktop robots. And then you take as many pictures of that item as you can. And here's a top tip for you. Take a 10-second video. So just get your iPhone out, and this is what I did. I walked around the fridge, and I took a 10-second video, and I loaded it into Photoshop, and I said to Photoshop, please render the individual frames of this video. At which point, I got about 890 frames, which was more than I actually wanted. So then you can just say, actually, just render every 10th frame. So I ended up with about 100 pictures of each of my objects. And doing it that way takes seconds. And then if you use Automata to do all the renaming, all this, this can be done very quickly, is what I'm saying. And the reason that's important is because then that allows you to experiment. It allows you to develop apps really quickly and really easily without a lot of hassle. So to build the whole object model behind this for about 7 different objects took me about 20 to 30 minutes. And, and that's great because it allows me to experiment. So once I've got my images, I then upload them into a data set within Einstein Vision, and then I train that data set. So I say to Einstein, go and look at all the images I've just given you, look at their labels, and then recognize those next time I give you something that looks a bit like that. And actually, it's very accurate. The documentation says you need about 1,000 images per label. I use about 100. And actually, I didn't even take real-life objects. I used 3D objects. So I trained it to recognize that fridge from a 3D object of that fridge, because it was just quicker and easier for me to do. So it can be very accurate, Einstein Vision. And then once you've done that and you've trained your data set, you then just give it a sample image and say, can you classify this image? And again, it will come back and say, this is what I think this image is, and this is how certain I am. So if it comes back and says it's 99% certain that it's a fridge, it's likely to be a fridge. If it comes back and says, I'm 0.1% certain it's a fridge, it's likely to be a dog or a cat or a squirrel or something else, but it's definitely not going to be a fridge. So the percentage gives you an idea of how confident Einstein is that it's what it says it is. But again, really good technology. We have our own built-in classifiers. So we have something called the general classifier, the scene classifier, and the food classifier for some reason. So if you just want to play with Einstein Vision, you don't even have to create your own classification model. You can use one of the pre-built classification classifiers, and just all of my early demos I did use the general classifier. You get some really weird answers at times, but it's actually pretty good. If you just want to recognize cats and dogs and cars and trees, it's fantastic. But you can also build your own classifiers, and you can build what I mentioned earlier, which is an Einstein object detection classifier as well. So that's when we're asking it to count the number of objects in a scene. And we have something called multi-label classification as well. So if you take a picture of a park, it will say, this scene contains a tree and a bench and a dog and a cat. It will come back with multiple things that are part of that scene. So very powerful. I really like Einstein Vision. And this is really basically exposed to you as a bunch of REST services that you call. You train and you program it via the REST services, and then you make predictions via the REST services. Unless you use this excellent piece of software that one of our evangelists wrote. So René Winkelmeyer wrote this thing called Einstein Platform Services. He wrote a blog on it. So if you just do a blog for René and Einstein Platform Services, it will point you at his code. And what René's done very helpfully is he's wrapped all of that Einstein Vision stuff into Apex. So you can just call his stuff from Apex. And he also wrote this thing called Playgrounds, which you've got a picture of here, which enables you to even create your models in your data sets and do your training from within an org. So René's made that stuff really, really easy to do. And your use cases for Einstein Vision are boundless, but things like visual search, brand detection, and product identification, which is, I guess, really the use case that I'm using it for. But you can imagine people like high street clothing stores who want to do social listening at an image level. Who's using my brand, who's wearing my brand, who's being an advocate for my brand. Those type of applications are doable with this sort of technology. I just wanted to show you this. There's not much code in this presentation, but this is the Apex I wrote that exposes a REST endpoint, takes a base 64 encoded version of the image, asks Einstein what the image is, gets something back from Einstein, runs the SOCL code to join the account, the customer, the service contract, and then returns it to the iOS app. So even when you have to go down into code and start using Apex, Apex can be really clean, and it can be really succinct. And I was a bit surprised when this all worked, if I'm honest. Because the SOCL statement is nice, because what it does, although I'm doing the select on an asset, I'm also selecting all of the sub-objects that are related to the asset. So when I actually return the asset at the end of this call, it will return JSON, there's the asset, plus all the related objects. Yeah, that makes it really, really powerful. One call to do all of that work. And then this is the bit I didn't show you in the demo, which is rendering the 3D objects in the org in Service Cloud for the service agents. This is, as promised, this is how you configure knowledge. the snap-ins. I know you can't read this, but I think we provide the slides, or certainly we probably can do. And as you can see, it's actually, that looks like 4 lines of code, but it's actually only 2 lines of code. There's a comment in there as well. I comment my code. Not very well, but I make a bit of an effort. So 2 lines of code, and I've told that iOS app to connect to a community, what product articles I'm interested in, their root category, and the category that I want it to display information about, and then that's it, you're done. You then just have a button or something in the UI that you press, and then you display that knowledge. The second one is the cases, where I log the case. That's even simpler. That's 1 line of code rather than 2 lines of code. And then the bit I really like is the SOS piece. And here, again, I've included comments, the function name, and a debug statement. So if you took all that out, it would be down to about 2 or 3 lines of code as well. And that enables us to do that live SOS call. So again, the snap-ins are really powerful. And then last but not least is the iOS app. And again, you need to know Swift, and you need to know a little bit about iOS. But actually what I did, I went online and did an AR kit training course on one of the online learning platforms. And I did it over 2 days. And after that, I was able to write relatively simple but usable AR applications. And I like AR. People are starting to say, is it limited? Is it going to actually, is there a future for AR and VR apps? But I think if you reimagine the way a user interface can be, and you start to think of a room and an environment becoming your user interface, I think it can be really powerful. And I really like the fact that ARKit, it gives you that world configuration. It tells me where I am in my space, and it tells me what I'm looking at and how I'm looking at and what my light levels are. So it handles things like camera positioning. It handles all the rendering of the 3D models and how they should behave in that space. It does things like light estimation within the scene. So how should I light my model? And I've even seen really interesting apps like where you'll have a picture of a scene with a light on, and there'll be like a monster sat on a desk, and you turn the light off and the monster jumps in the air because there's no light in the scene anymore. So not only can you light your models based on the light in a scene, you can actually make the model start reacting to how much light you've got in the scene. And the plane detection is great because now I can do, with ARKit 1.5, it will do horizontal and vertical plane detection. So you can start putting things on walls as well as on floors. Great if you want like a virtual dartboard or something like that. It's fantastic. And of course, something I'm going to show you in a sec, if we've got time to do one last demo, which is image recognition. But very, very different from the way Einstein does image recognition. So with ARKit image recognition, I've got some pictures on the floor here I'm going to use in a second. You can use these as anchors in the scene. So I can ask ARKit to render something on top of that picture. So imagine taking out a business card and you're a taxi driver and you get a picture of a little taxi and it starts spinning around. Or your Salesforce AE gets his business card out and you get the Salesforce cloud appears and starts spinning around. That's the sort of stuff you can do with ARKit image detection. It's really powerful. I really like it because it's not actually telling me what that image is, but it's saying, what I'm saying is I want that image to be an anchor for a 3D model. And you can start doing some really nice things around that. And hit testing. So you saw that when I had my AR model up, I was able to interact with it. And that uses something called hit testing. So when I push the screen, it elongates my touch into the scene and works out whether I hit any of the 3D objects. And if I do, I just get a callback that says this is the 3D object that you hit. So that's how I make the panels transparent. It's how I use the pinch gestures to resize the panels. Again, hit testing is a really powerful concept and idea, and it sort of comes free of charge with ARKit. And what type of apps can you build? Well, people like IKEA. Has everyone seen the IKEA app? Where you can place furniture and see how great it's going to look in your apartment before you buy it. BMW have done some really interesting things for consumers around, if you're going to buy a BMW car, you can see what it looks like in your driveway before you buy it. You know, the color that you've asked for and the wheels that you've put on it and everything, you can see how it looks. But you can also get inside the car and see what the interior looks like, depending on whether you choose cloth or leather and how you set the car up. You can actually get inside your virtual car before you've even bought it and decide how you want it to be spec'd out. I showed you the field service enablement and the augmented knowledge, but I think where this is really outstanding technology is things like museums and galleries, exhibitions, and education. One of the first apps I built as part of my course was this solar system. And I had a solar system in my living room with the sun and the planets, and it was all rotating around in relative time. And you show that to a 6-year-old, it's amazing, right? Suddenly you're picturing the solar system in your living room. It's breathtaking, actually, to see their reactions. So, and of course, Pokemon Go, right? There's always Pokemon Go as well. So I'll show you one more quick demo. The technicians did say we're on last today, so I can go on as long as I want, so I assume that's okay. But I also realize that I'm between you and happy hour, so this will be a short demo. This is an example of something we built for World Tour Australia, and it's a very bad play on words. Welcome to IOT Fields, right? And you're growing and picking tea. So what we wanted to do is we wanted to have tea growing, and we wanted to have planters, and we wanted to have different weather conditions, and we wanted to create a game where, depending on what the weather condition is in the coming days, you determine how you should irrigate your tea planters. So we didn't want to build tea planters. So what we did is we wanted to use this image recognition. So hopefully this will work on these services. But as you see, as I hover over these images, the AR kit picks up those images and then starts rendering these virtual planters on top. That one's gone a bit wonky for some reason. It's probably, and you can see that we've also got virtual objects. So when it's raining, we have rain clouds. And you can see that the tea is actually growing within the planters. And depending on how wet your planter is and what the weather conditions are, your tea will grow at different rates. So again, that's a completely different user interface. It's something completely different, but I just wanted to give you a quick idea of something that we built for World Tour Australia as well. So with that, just a couple of resources for you. Salesforce developer site, the Electric Imp Trailhead, a link to Service Cloud snap-ins, Einstein Platform Services, and Apple AR Kit, which we used to build this demo. With that, slightly over time, so thank you very much for your patience. I realize we're the last session of the day, and you've been a great audience. If you have any questions, I'm happy to take them. But other than that, enjoy the rest of your Trailhead DX. Thank you.